Hey, it's Poisson Variants, your VTuber math lover gamer and nonsense enjoyer, and today we're going to be talking a little bit about one of the hurdles we see a lot in mathematics. Now, one of the first hurdles that people run into tends to be algebra. Adding letters with numbers is something that can throw a lot of people off and can seem really confusing. After that, a number of people tend to get caught up on trig and proofs and that whole concept. But one of the biggest hurdles that stops people from continuing in math is calculus. Now, calculus doesn't have to be scary. In fact, I find that the toughest part of calculus is just the algebra. But if calculus isn't so scary, then we have to answer the question, what is calculus really? Well, first we gotta ask, what's a function? When we think of a function, we generally think of stuff that's like plug and play. Plug in a value, you get out another value, and you plot it. Y equals f of x. This can take the form of linear equations, or quadratic equations, or polynomials. What's nice about these is that they can be modeled visually. You can see a distance traveled on a graph, or you can see the trajectory of a ball thrown pretty easily on a graph. With that in mind, then we can think of calculus at its most basic as just an analysis and modeling of functions. We can see how calculus terms and ideas can be represented visually. Tangent lines, critical points, definite integrals, they're all concepts that can be seen on the graph of a function. But those same concepts also refer to other graphs that relate to other calculus concepts beyond just your initial functions graph. But again, we're looking at graphs. The focus of calculus is just pictures. All of our visual representations and visual concepts also have algebraic and equation forms. Now, I find that the tricky part comes in matching the equations to the corresponding graph of the function and the different pieces that it interacts with. In a way, you want to place each formula with a section of a graph, or a section of a function. That way, if someone says, what's the airspeed of a thrown baseball at this place in time? You can look at a graph and think, well, if I want the speed to a certain time, I can take the derivative of position to get velocity at said time, and the slope of my tangent line is my derivative at the specific point, so I'll need the derivative of the function for my position versus time graph. As with anything, once these concepts are more embedded in your brain and associations have been built, then callback will be easier. Then one day, suddenly, calculus won't seem so scary. You'll be able to connect concepts to concepts, visuals to visuals, and equations to equations, and any combination of those. The trick is getting over that first scary hurdle. Anyways, I've been Poisson Variants, your VTuber, math lover, gamer, and nonsense enjoyer. Thank you all for watching, and bye-bye!